Hi, I'm going to try and answer your questions with a quick video. Alright, so let's look at number 72. It says, assume that you invested 10,000 in each of 3 stocks. Each stock can increase in value, decrease in value, or remain the same. Drawing the probability tree for this experiment will show you that the number of possible outcomes is... Okay, so basically here you have 3 stocks, and each one of them can do 3 things. Increase in value, decrease in value, or remain the same. So let's do it like this. My first stock, sorry, I've got to pick a different color here. My first stock can either increase, decrease, or stay the same. My second stock will either increase, decrease, or stay the same, increase, decrease, or stay the same, increase, decrease, or stay the same. And then finally the third stock is going to do the same stuff, right? So I'm going to have 3 at the end of every one of these. So this first column here is my first stock. I have to see what happens with the first stock. So it's either going to go this way, or this way. But then after the first stock has been determined what goes on with it, and there's 3 things that could happen with that first stock, then there will be whatever happens with the second stock. So there's 3 things that could happen after my first stock increases. There's 3 things that could happen after my first stock decreases, or there's 3 things that could happen after my first stock stays the same. So I'm up to 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities. But then my third stock, so that was my second stock. Sorry, this is a little bit sloppy. But then this last set here of branches, that's my third stock. There's so many of them because what's happened before, well, there's nine combinations of what could have happened before. Either the first increased and then the second increased, or the first increased, the second decreased, and so on. So my third stock is what gets decided by these smaller branches here. Now there will be 1, 2, 3, 4, 5, 6, 7, 8, 9 of these, each with 3 parts. So 9 times 3 is 27. There are 27 unique pathways through this tree. So let's see. Here is one pathway. That's just one. And here is maybe a second pathway. There. There's a total of 27 pathways. So how does that help us with this? 27. The answer is D. So that's how you get to that answer. All right, now what about 73? 73 says an experiment consists of tossing 3 unbiased coins simultaneously. Drawing a probability tree for this experiment will show that the number of simple events in this experiment is, well, 3 coins means I'm going to have 3 branches on my tree. So, it's going to have, there's going to be 3 selections being made. Heads or tails is the first coin. Second coin will be heads or tails. Depending on what's happened with the first coin, I either have heads first and then heads or tails, or I have tails first and then heads or tails. And then the third coin is, just 2 of these, will be heads or tails the whole way through. So it's going to be 2, 4, 6, 8. And 8, 8's not on there, so none of the above is correct. All right, so what about 74? It says, if the events A and B are independent, A equals to 30 and B equals to 40, 40%, 30%, then the probability that both events will occur simultaneously, well, if you have 2 independent events, then the probability of A and B is simply just the probability of A times the probability of B. This is just the multiplication rule in your textbook. So it's just going to be 0.3 times 0.4. So that's equals to 0.12. So that's all that one is. Hope that helps.